All right, gentlemen. So we are going to be learning today about some additional derivatives. I just want to remind you of some of the derivatives we've talked about so far. We can do graphical derivatives. We've done definition, we've done power rule. And then last class we talked about product rule, quotient rule, the derivatives of sine of x and cosine of x. And then we used quotient rule. Again, that's the low d high minus high d low over low squared, and off you go. To find the derivative of tangent using our quotient identity. So we're going to add to that today. First we're just going to review, I guess. So we're going to start out with the derivatives of cosecant and cotangent. Just like we did for tangent, we're going to use sine and cosine to rewrite these. So cosecant, if you remember, is the same as 1 over sine of x. And just like I said in class, eventually you'll memorize these, but for now you can use quotient rule to find those derivatives. So we're going to set up our low-high chart, and then our d-low and our d-high. And our low is sine of x. I did not give myself very much room here. The high is just 1. The d-low is cosine x, and then the d-high is 0. So a lot of stuff is going to simplify. So we're going to set it up. We have f prime of x is equal to low d-high minus high d-low over low squared, and off you go. And if it doesn't rhyme, it doesn't work. So sine times 0 is 0. We get minus a cosine x all over sine squared x. Now, this is not the simplified version, and this is not how you're going to see it written most of the time. This is the same as negative 1 times a 1 over a sine, and then times a cosine over a sine. Now, there's a bunch of different ways using trig identities that you could simplify this. This is how we're going to. So we end up with that negative 1, so it's going to leave us with negative 1 over sine is equal to a cosecant of x. Don't lose your of x, otherwise it's going to be a totally different thing, times a cotangent of x. So this one's pretty messy, but that's our derivative of cosecant. We get negative cosecant x, cotangent x. Let's do the same thing for cotangent. So again, cotangent is the reciprocal of tangent. We can still use our quotient identities to plug in a cosine over a sine. And then again, we're going to set up our low. Oops, let me write this as high. And then our d-low and our d-high. Our low is sine of x. Our high is cosine of x. Our d-low is cosine of x, and our d-high is negative sine of x. Okay, and then we're going to do f prime of x is equal to sine of x times a negative sine x. And then don't forget, with quotient, it's a minus. So minus a cosine x times a cosine x all over our low squared. So all over sine x squared. So this gives me a negative sine squared x, and then minus a cosine squared x. So this is also going to be an identity, even though it's not as obvious. And then again, over sine squared x. So what you can hopefully see is that you can factor out a negative 1 there, and you'd have sine squared plus cosine squared if you factored out that negative 1. And then again, that's all over sine squared x. Well, sine squared plus cosine squared, as we talked about in class earlier, is just equal to 1. And so you're ending with negative 1 over sine squared. Of course, that's not the most simplified version. We can get that to be written without a fraction using our reciprocal identities. So we get negative cosecant squared x. So those are 2 additional trig identities. We're going to go through the rest of them. So you can copy these down. Make sure this is in your notebook somewhere so you can easily find it as you're learning these. Again, sine and cosine we did with the graphs. You can always come back to that, and you can start with sine and go through that little table I showed you. But here are the derivatives of each of these. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. We did those 3 in class. Okay, the derivative of secant is secant x tangent x. The derivative of cosecant is negative cosecant x cotangent x. And then the derivative of cotangent is negative cosecant squared x. There's a couple little patterns, nothing crazy or super helpful to memorize, but you will notice that all of the functions that start with a c all produce a negative derivative. So it's one little pattern to note. So all of the functions that start with c are going to produce a negative derivative. And then there's some similarities, like tangent produces secant squared, cotangent produces negative cosecant squared. Secant and cosecant both have their functions within their derivatives. But again, you can find these using quotient rule, and you will eventually memorize. Let's talk about chain rule. I made it really big so that you knew it was super important. Chain rule happens when there's functions within functions. So if you have a function inside of a function, you are going to be using chain rule. Oops, sorry about that. So if I have f of g of x, you guys saw that probably in pre-calc and algebra 2 when you did composition of functions. The derivative of that is going to be f prime, and you're going to leave the inside function alone exactly as it was. So f prime of g of x, so take the derivative of, I'm going to call that the outside function. The f of x is going to be the outside function. Okay, you're going to leave the inside function alone, and then you're going to multiply by g prime of x. Okay, that's the formal definition. That's how you're going to see it written in a lot of places. So you take the derivative of the outside, leave the inside function alone, and then you multiply by the derivative of the inside function. Let's look at an example. So this example, I have 4 parentheses 11x to the 5th minus 6x, and that whole thing cubed. What's helpful to think about is just the outside function by itself first. So the outside function is 4 something cubed, right? Let's say it was 4x cubed. We'll think about this just off to the side for a second. So 4x cubed, but we're going to just leave the inside of that alone, right? So 4 something cubed. If it was an x, of course you would know what to do. You would take the 3 and multiply it by the 4, so you would use power rule on that outside function, and you'd have 12x. If it was an x here, you'd have an x here, okay? And then you'd raise it to the second power. Okay, that's how you would do that outside function. So that is the derivative of the outside function. When I'm doing h prime of x, the first thing I'm going to write is the derivative of the outside function, because that's this blue part here, the f prime, right? So I'm going to have 12 something squared. Okay, that's the derivative of the outside function. So 12 something squared. Okay, but I'm going to leave the inside function alone. So I'm going to leave the inside function exactly as it was. 11x to the 5th minus 6x is going to stay exactly as it was. And then what I'm going to do is I'm going to look at the inside function, which is right here, and I'm going to multiply by the derivative of it. So I'm going to multiply by the derivative of 11x to the 5th minus 6x, which is 55x to the 4th minus 6. Okay, and a lot of times you can leave it here. You know, if you've got something super simple at the end and super simple at the beginning, of course, combine those if it's easy. But otherwise, you can just leave it here, and this is our answer. So how come we haven't been doing that is a question a lot of students will ask. Like when it was 4x cubed, we just did 12x squared as the derivative. Well, the reason, because you were secretly doing chain rule anyways, is because you're multiplying by the derivative of the inside function, but the derivative of x is just 1. Okay, this is going to help us attack those derivatives where there's a parentheses or a square root and we haven't had a different method to solve them. So let's look at another example. Sine of 5x. Okay, we have to first identify the outside function. So the outside function, if you're saying sine of x, the of is kind of a hint, okay, that the of is the inside, whatever you say after that. Whatever you've said first, so sine of that, sine is the outside function. So the derivative of sine is cosine. So we're going to have cosine of something. That's the derivative of sine of something is going to be a cosine of something. Okay, now remember, we're going to leave the inside function alone. So it stays as 5x. And then I multiply by the derivative of that inside function. So the multiplication is times 5. And like I said in class, often you're going to see this with a number in front of your trig. We just like to move it to the front, but it's exactly the same as if you have it at the end. Okay, so the derivative of the outside function, leave the inside function alone, then multiply by the derivative of the inside function. Let's look at another example. There's a couple ways you can do this one. Most guys, when they see this, especially as we're learning our current things that we're going over, they assume, well, I got to do quotient rule, and then within that quotient rule, when I do my D low, I've got to do maybe chain rule with this square root, or maybe they don't even see it at all, and they think I can just deal with that square root. We talked about the fact that you can't break the square root up because there's addition or subtraction, okay? And you actually don't need quotient rule for this one. You can do it just with power rule and chain rule. And we're going to start by rewriting this. So this is the same. We know that this is the same as 8 over 3x plus 1 to the 1/2 power. That's the same as what a square root means. It means a 1/2 power, okay? But this would still be a quotient the way it's written. I still have a function divided by another function. So I'm going to move that denominator up. And by moving it up, I'm going to change it to 3x plus 1 to the negative 1/2. Okay, now my outside function is 8 something to the negative 1/2. That is now my outside function. So when I take my derivative, the first thing I do is take the derivative of the outside function and leave the inside function alone. So that's going to be, I'm not going to simplify it first here just so everyone can tell what I'm doing. So I'm doing 8 times that negative 1/2, right? And then I'm leaving the inside function alone and I'm subtracting 1 from the power. Because that's, if it was, 8x to the negative 1/2, you'd take this, multiply it, and then subtract 1 from that power. So it's exactly what we're going to do here. We're going to have 8 times that negative 1/2 and then raised to the negative 3/2. Again, inside function stays exactly as it was, 3x plus 1, going to stay exactly the same. And then I'm going to multiply by the derivative of the inside function, so times 3. Okay, let's simplify this. So we have a negative 4 from the stuff out in front, that's a negative 4. And we have a times 3, so that's pretty simple to put together. A negative 4 and a times 3 is a negative 12. Okay, and then I have 3x plus 1 to the negative 3/2. Now sometimes you might see this rewritten with radicals back in it. So just to be clear, that would be the same as negative 12 over, and that would be the square root of 3x plus 1. And they might put the cubed on the inside like this, or they might put it on the outside of the radical. And both of those are the same thing. Okay, just to be clear, on a quiz or test or homework, you're welcome to leave it just like this unless I ask you to specify or ask you to simplify it or get rid of negative powers or something like that. All right, let's keep going. So this one gets a little trickier because now I have functions inside of other functions and I have more than one. So in the previous couple examples, we had one outside function and one inside function. But with chain rule, sometimes you have more than one of those inside functions. And so you always want to work from the outer function, the most outer function, the outermost function, to the innermost function. So you'll notice it's sine of cosine of 3x. So my outermost function is sine. I'm going to use some colors to underline some things. So my outermost function is sine. When I take the derivative, I'm going to get f prime of x is equal to, and I'm going to take the derivative of the outside function. So the outside function of sine is going to be cosine. And I'm going to leave the inside stuff alone. So the inside stuff is going to remain cosine of 3x. So all I've done so far is take the derivative of sine, the outside function. Then I'm going to work my way in. Okay, so the next inside function is cosine. So the derivative of cosine of some stuff is going to be negative sine of that stuff, and I leave that stuff alone as well. So I'm going to get negative sine of 3x. Okay, that's the derivative of the cosine. Last thing I'm going to do is I'm going to take the derivative of the innermost function, which is 3x. So I'm going to multiply everything by 3. Okay. You can't call this like cosine squared. It's not cosine times cosine. It is cosine of cosine of 3x. Okay, and then it's times a negative sign. So really the only thing you could do to simplify this, if you wanted to, and it's fine as is to take, negative and the 3 and maybe move those all the way out in front. So negative 3, and then cosine of 3x times sine of 3x. That's maybe the most simple it can be. Okay, there's some other identities that you could potentially use, but we're not going to get into that. This is good. Let's go on to the next one. So the next one is cosine to the 4th. Well, let's pause real